Okay, in this video, I show how to use the implicit plot function in Sage Math to plot a line. So let's see. So here's this question we start off with: find the equation of the line through a given point p naught is equal to 1, 2, with a normal vector n being negative 1, 3. Okay, so the solution to this problem, just in terms of math, is okay, let p be an arbitrary point x comma y on the line. Then by the definition of the normal vector dotted with the vector from p0 to p has to equal 0, and then substituting what the normal vector is along with what the vector from p0 to p is, we get all this math, and then the equation of the line is at the very last equation down here, negative x plus 3y minus 5 equals 0. So that's the equation we want to plot. And so let's introduce our variables x and y. And then here's the call to the plot function, implicit plot. Here's our equation. Now, importantly, we want to write equals equals instead of just a single equals. That's because this in Sage equals is a single equals is the assignment operator. Here we want to plot not the assignment operator, but the comparison of when is this function negative x plus 3y minus 5 equal to 0. And okay, so then we enter the range of x. I've chosen x to range from minus 5 to 5, y to range from also minus 5 to 5, and then included the axes and color these later to are just options. Okay, and then I'm calling that plot object p, and then I ask what is p equal to, and okay, so then it's this line here. So this is plotting the equation of this line, negative x plus 3y minus 5. Okay, now here's, well, let's see, what did I do next? Well, here's, you can just add in the point p by this command here, p plus the point 1, 2. So there's it, if there's it in blue, and then you can add in the normal vector. So if I do p plus the plot of this vector, now when you just plot just the plain vector, it starts at the origin. And if we wanted it to start at the point p, which is a little bit nicer, enter this command start equals the original point that you would start off with, 1, 2, and so now we have this plot here. Now let me do this problem a different way, where we go back and use this equation, this very first equation here, or and because Sage Math does have the capability to compute dot products. Okay, so let's let n be our normal vector. So I've entered it as vector minus 1, 3, and be sure to have these double parentheses. If you use single parentheses, you'll get error. And then let p be the tuple 1, 2. So then when I ask what Sage, what are n and p? Well, n is this and p is that, and they look like the same type of object. And from a mathematical perspective, yes, they are. But from a computer science perspective, they're different. If I ask what is the type of n, what type of object does Sage think n is, and what type of object does Sage think p is, they're different. N is basically a vector. There's a whole bunch of information here, but basically a vector. And then p is a tuple. Now, in math, a tuple and a vector, they're basically the same thing. But why am I highlighting this? Well, if you do n minus p, if you try to subtract a tuple and a vector, you'll get an error. This fairly unintelligible error, actually. But okay, and then so what I was trying to do was, let me go back up here. So I was trying to enter this equation, the second equation here, or where I've got x comma y minus the point p times the normal vector n, taking the dot product, and that's what I was trying to do, but I was getting some errors, and I just wanted to show you what those errors were. So here I did, x minus y, sorry, x comma y minus p. And again, the problem here is x comma y is a tuple. And as we saw earlier, you can't subtract a tuple from a vector. Or sorry, yeah, p is just a tuple. And actually, you can't subtract two tuples. You can't subtract a tuple and a vector as well. But anyway, so what we need to do is we need to convert them to vectors, and then we can subtract. So here's what I tried to do, vector xy minus vector p, and that's closer to the answer, but what I forgot to do is put double parentheses around this vector, call to vector. The call to here is fine, but here I'm passing in the tuple xy, so I need to include that in its own parentheses. Okay, so now finally, I got the correct syntax. I'm taking n times, and the dot product of n, the normal vector, with the vector xy minus the vector p. Let me again go back up here and show you that this is basically what's happening in this second line. Okay, and then Sage can compute that dot product once you enter it correctly. And so, okay, here, this is exact same answer we got above, or by, in the by hand, basically. So, okay, and let me store that as G. And now it's kind of the same thing about doing that implicit plot of G, the same range, and let me call it plot 2. Here's what plot 2 looks like. And now I've just added, again, the normal vector starting at P. And okay, great. Now I also wanted to add in the point, the P1, 2, and when I tried entering that code, well, I tried this, but I got an error, and so what did I do? I did plot the point P, and then I want to make it a little bit of a bigger dot, so I'm going to say size equal 10, and I decided the color to be black, and I got an error, and it's almost correct, but the issue is the size and the color attribute, when I'm trying to plot a point, need to be part of the point, the call to the point function. If you're plotting a vector, this would be fine. But if you're plotting a point, you need to put size and color as part of the call to the point. So it's very subtle distinction. It might take a few moments to realize it, but I just wanted to point out, if you get this type error that says plot got an unexpected keyword argument, that's likely a cause. Okay, and then here's our plot. Here's our point P.